Okay, we're going to look at the sum of an infinite series. So what does that look like? That means basically we're going to add together all terms. So this would be like n equals 1 to infinity of your sequence. Or sometimes you'll see an n equals 0 down here. And that's okay. Because the n just tells you which term you're starting on. But if you're adding to infinity, you're already counting all of that in anyway. So it's not that big of a deal. Here's what this is. Look, I can't just give you the formula and feel good about that. That's not my way. I'm going to show you where this formula comes from. So, I mostly anticipate that my A3 students are watching this right now. So this is all going to kind of be new. And this kind of ties into where did the sum formula for the finite come from last time. So here's what we got. Let's say I have a sub n equals a1 times r to the n minus 1. And if I want the sum of an infinite amount of terms of this, that's like adding everything together, every term that existed, plus a1 times r3, and keep going on until we get 1 times r to the infinity, right? It's just going to be infinite. Well, so what we're going to do, this might not feel very intuitive in this situation, and that's okay. If I'm going to take this and I'm going to multiply it by my common ratio. And what that does is now that takes my first term. This one will now be times r, so I'm just going to line it up here. Say 1 times r. And it essentially just shifts every other term, because now my second term, which is a1 times r, well, now it's going to be a1 times r squared. And it basically shifts everything over. And I can't have infinity plus 1. That's not a thing. So this also goes to infinity. And now what I'm going to do is I'm actually going to subtract these two terms. So I'm going to do the infinite sum minus r times the infinite sum. You might think, why would we do that? Well, if I'm looking to subtracting this bottom one, I should notice that all these terms start canceling out, like every single one of them. So that leaves me with just my first term. And then I'm going to factor out the s infinity part. So that leaves the sum of the infinity. Well, sum infinity divided by sum infinity is 1. And then it'll just be a minus r there. And now I can divide by 1 minus r. And that is the formula for the sum of an infinite geometric series. But something to keep in mind, like we talked about converging, diverging, if my series was diverging, meaning it was approaching an infinite value as we keep going, you would never be able to add those all together because the numbers would just keep getting bigger and bigger and bigger. So this only happens when the series converges. Which, as a reminder, that's when we have a common ratio that's less than 1, the absolute value of it. So let's look at some examples. Gotta pull up my examples here. Okay. I'm gonna write my formula over here. So let's say plus the sum of 3/4 to the n minus 1 power. Okay. Well, in this situation, I can see that my A1 is going to be 5/3. I can see that my common ratio is 3/4, which means awesome. This is converging, which means we can use our sum formula. We can find the sum. And so I'm just going to plug it into this formula over here that we have. So this is 5/3 is A1 divided by 1 minus 3/4. And so now we just need to know some order of operations here. 1 minus 3/4 is 1/4. And to divide fractions, we keep the first and we take the reciprocal of the second, and now we just multiply them together. That's it. Sweet. So I got another example. Maybe we have, let's see, 1/5 plus 2/15 plus 4/45 plus 8 1/35. Okay, this time the sum wasn't given to you. Bummer. So you're going to have to figure out what that common ratio is. So I'm just going to look, between these. What's up? 5 to 15, I had to multiply by 3, and it looks like that's keeping consistent on the bottom. And 1 to 2, I had to multiply by 2. 2 to 4, multiply 2. Sweet. So R is going to be 2/3. And that's also a converging value because it's less than 1. So I can take my first term, which is 1/5, and divide it by 1 minus 2/3. So that's 1/5 divided by 1/3. So that's like 1/5 times 3. And we get 3/5. Sweet. Okay, one last example. Let's say I have 8 minus 10 plus 25 over 2 minus 125 over 4 plus. Okay, we have an alternating series in this one. And if I wanted to find, if I ever don't see it like on this example that I just did here, like the fractions I could more easily see. Here I can't see it, so I can just take any term and divide it by the one before it. So I can do -10 divided by 8, and that's -5/4. Well, this is a diverging value of R, which means that the sum does not exist. All right, that's the lesson for today. Good job, everyone.